Hello everyone. Today is BSc first year, first semester paper. Paper name is Mechanics of a Particle and lesson name is Center of Mass and Center of Mass of a reduces mass also. Now we discuss the Center of Mass lesson topics. Center of Mass is center of mass of a rigid body and reduces mass. What is the center of mass and center of mass of a rigid body is also explained now. So what is the center of mass? Center of mass is the any two particles. Okay, center of masses of a is a position defined relative to an objective or systems of object. It is the average positions of all the parts of the systems weighted according to their masses for simple rigid objects with uniform density. The center of mass is located at the centroid. Let us consider any two particles of masses m1 and m2. On the x-axis of the distance is x1 and x2 from this origin, and the center of mass of the two particles is now in this figure observation. So this is the origin point. So m1 and m2 particles. So origin first mass m1 is distance is x1 and another mass m2 is the mass is distance of x2. So m1 and m2 is mass of the center of mass is this one, center of the masses. So this is symbol of xcm. So this is the origin to center of mass. So you can define the xcm. So now center of mass of the two particles is defined as the xcm is equal to m1 x1 plus m2 x2 by m1 plus m2. Any two particles are in the xy plane of the coordinates x1 y1 and x2 y2. The coordinates of the center of the mass is defined as the xcm is equal to m1 x1 plus m2 x2 by m1 plus m2. Similarly, y-axis, that is center of mass of the particle, that is ycm is equal to m1 y1 plus m2 y2 by m1 plus m2. If there are more than two particle distributions in the space of coordinates of the center of the mass of these particles is defined as the cm is equal to m1 x1 plus m2 x2 by m1 plus m2. The center of the mass of the y plane, so ycm is equal to m1 y1 plus m2 y2 by m1 plus m2. If there are more than two particle distributing in the space of the coordinates of the center of the mass of these particles is defined as the xcm is equal to m1 x1 plus m2 x2 plus m3 x3 up to n number of particles by m1 plus m2 plus m3 dash 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 n particles. That is equal to number of particles. You can write summation of I equal to 1 to n mi xi by summation of mi. So similarly, y axis, the center of the mass of y plane is ycm is equal to m1 y1 plus m2 y2 plus dash dash up to number of particles by m1 plus m2 plus dash dash number of masses. You can write summation of I equal to 1 to n mi yi by summation of I equal to 1 to n, that is mi. So similarly, zcm, the center of the mass of the z plane is equal to m1 z1 plus m2 z2 plus dash 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 by m1 plus m2 plus up to number of masses, that is equal to, you can write summation of I equal to 1 to n mi zi by summation of I equal to 1 to n, that is mi. You can write this is the summation of I term, I to 1 equal to number of particles. So now these three equations, that is x, y and z plane, to give the position vector of the center of the mass, that is the center of mass of the position vector rcm, that is equal to I into xcm plus j into ycm plus k into zcm. So he can write xcm, ycm, zcm is values. So equation 1 and 2, these three equations xcm, ycm and zcm values is substituting in this equation, that is simplification summation of I mi, that is here both are the common of the mi values. So mi is the common, I into xi plus j into yi plus k into zi by summation of mi. Now we can write, that is I into xi plus j into yi plus k into zi. So you can write that is the position vector ri. So rcm is equal summation of I equal to 1 to n number of, that is mi into ri by summation of I equal to 1 to n number. So that is into mi. So this is the rcm position vector of the center of the mass rcm is equal to in equation 3. So we can write summation of I into mi in this the total mass of the system. Let us consider capital M. So now we can write total mass of the system capital M, substituting in three equation, that is rcm is equal to summation of I into mi ri by capital M. So is equal to outside వెళ్ళినట్లయితే m into rcm is equal summation of I into mi ri, that is equation of 4. So now this fourth equation differentiating with respect to t, so you can differentiating with respect to, so that is m is the constant and differentiating with respect to t, then RCM, so dRCM by dt, so is equal summation of I into mi is constant, dri by dt. You can write dri by dt, that is the distance by time is equal to velocity, so dri by dt is equal to vi and drcm by dt is equal to vcm. You can write after differentiating this value is substituting, we get the value m into vcm is equal summation of I into mi vi. So this is the equation 4, differentiating with respect to t, then this values is substituting dri by dt and drcm by dt value is substituting in this simplify, that is m into vcm is equal to summation of I into mi vi. So this is the equation of the total, this is the right term, this summation of I into vi value is the total linear momentum of the particle and is called the total momentum of the system. So again differentiating in this equation with respect to t, so m into dvcm by dt is equal to summation of I mi into dvi by dt. Now you can write dvi by dt is equal to acceleration, that is velocity by time, that is equal to acceleration, ai is equal to dvi by dt. So similarly acm is equal to dvcm by dt, then this value is substituting, then we get this final value m acm is equal summation of I into mi into ai. So this is equation 5, differentiating with respect to t and acceleration values, this values is substituting, final the equation m into acm is equal to summation of mi ai value. Let us consider this equation is 6. Now you can write equation 6, this is the right term is equal to, that is Newton's second law. Newton's second law is equal to F equal to ma, so you can write Fi equal to mi ai. So there is the force acting on the ith particle. So the right hand side this equation, the resultant of the force acting on all the particles are the resultant force acting on the system. Now we can write that is m acm is equal to summation of I into fie plus aie, summation of I naught is equal to j into fij. Here Fi is the external force acting on the ith particle and Fi into j, this force of the interaction. So this is the ith particle due to the jth particle. So Fij will be equal and opposite to the force of Ij into I. So acting on the jth particle due to the ith particle. So you can write Fij is equal to Fji also. This force of interaction between the particles on the system is equal and opposite pairs and hence they cancel in both each other. So the resultant force of the system is both are cancelled. So now you can write MACM is equal to summation of I into FIE. So is equal to, that is the denoted the total force acting on the system is, you can write F, so that is F is equal to summation of F into IE. You can write that is FE. So FE is the resultant external force acting on this system. Now this value is substituting in equation 6, that is MACM is equal to FE. So this is the F equal to MACM. So this equation is the center of the mass of the acceleration through the total mass of the system is concentrating and the resultant force is applied to it. So this is the force is equal to MAC. So this is the center of the mass as acceleration as through the total mass of the system. So next one, center of mass of a rigid body. Let us consider any rigid body. The center of mass of a rigid body can be determined by subdividing the body into the large number of small elements of the mass, that is del m is located. At the point is xi, yi, zi, the coordinates of the center of the mass r is given by xcm is equal to summation of del mi xi by summation of del mi. And similarly y-axis, that is ycm is equal to summation of del mi yi by summation of del mi, and similarly zcm is equal to summation of del mi zi by summation of del mi. So these are three points, that is xi, yi, zi, the three coordinates of the center of the mass of the given these equations, xcm, ycm and zcm. So if the number of mass elements tends to infinity, and then the summation in the above equation you can write replaced by the integration. You write the summation replaced by the integration. So xcm is equal limit of del mi tends to infinity of summation of del mi xi by summation of del mi is equal, you can summation replace the right integral. So integral of x dm. So you can write dm is the that is dm, and xi term is the, you can write x by summation is replaced by the integral. So integral of dm is equal to 1 by m into integration of x dm. So you can write integration of dm means that is 1 by m, integration of x into dm. Similarly ycm, the center of the mass of the y plane, ycm is equal limit of del mi tends to infinity of summation of del mi yi by summation of del mi, that is equal to summation is replaced by the integral, that is integral of y dm by integration of dm. So integration of dm is means that is 1 by m, integral of y dm. So similarly z axis is also, you can write zcm is equal to 1 by m into integral of z dm. So vector notation, that is rcm is equal to 1 by m integral of r dm. So rcm is equal to, that is the position vector, center of the mass of the position vector, rcm is equal, you can write 1 by m into integral of r dm. For homogeneous object having a point, a line or a plane of symmetry, the center of mass will lie at the point, on the line and in the plane of symmetry. For example, the center of the mass of the homogeneous sphere lays at the center of the sphere, and the center of the rectangular plane sheet lies on the plane of symmetry and is given by the intersection of its plane of symmetry. So this position of the center of the mass of symmetrical structure in this figure, that is the center of the mass, and rectangular and triangle, and these are both are square, these are also etc. This is the symmetrical structure of the center of the masses. And next one is reduces mass. Reduces mass means a small mass m coupled by the spring, and spring constant is k. To a rigid support, it is a simple harmonic oscillation. This is a two body systems in which the rigid support serves as a body with infinite mass. When the mass m attached to the spring executes oscillates, the rigid support remains at a rest in an inertial reference frame, and the potential energy u of x of the oscillating system is a function of the displacement x of the mass alone. So let us consider any two bodies of the masses, that is m1 and m2 is connected to the less spring of the force constant, that is k in this figure. The system is free oscillations on a frictionless horizontal surfaces, and let us consider that is origin is distance of mass m1, that is distance is x1, and again m2 mass is the distance of the origin, that is x2. Let us consider that is the within time, that is t. So x1 of t and x2 of the is represented the coordinates of the end position of this springs. So the center of gravity of a homogeneous sphere are like cube and circular and rectangular etc. These are the centers. So these two masses is considered, that is m1 and m2. This is the center density, manaki m1 mass ki distance x1 and m2 mass ki, that is the distance of x2, and this is the spring connected in this two masses, that is the spring constant is k. And again another figure, it is only one body of the system with reduces mass connected by a spring is fixed point, and another one, this is the only one body of the system, this is a reduced mass connected by the spring to a fixed point. The length of the spring at a instance of the, that is the x1 minus x2 if the unstructured length of the spring is the L, and then the change in the length of the spring is x is equal to x1 minus x2 minus L. So this is the only one body, and this is the body system is reduced mass connected to the spring in one fixed point, and this is also, this figure is x1 minus x2, length is only one body. You can consider rest in position, unstructured length of this string is the L, then the change in the length of the spring is total, that is x is equal to x1 minus x2 minus L, and then applying the second Newton's law. So that is m1 m2 we get, that is you can write the m1 into d square x1 by dt square is equal minus kx, and m2 into d square x2 by dt square is equal to plus kx. This is positive of the string is stretched. If x is equal 0, the string as its normal length, and is negative of the compressed, the string b is stretched, that is x greater than equal 0. Then applying Newton's law in both two masses, that is m1 and m2. So m1 into d square x by dt square is equal to minus kx, and the m2 into d square x2 by x square is equal to kx. And this is, let us consider in equation 2 and equation 3. Now you can write x1 is the change in the length of the spring, that is x is equal to x1 minus x2 minus L. So this equation 2 is multiplying in m2 value, and equation 3 is multiplying in m1 value. So after multiplying, this both are equations is subtracting. Finally, this value is m1 m2 d square x1 by dt square minus m1 x into d square x2 by dt square is equal to minus m2 kx minus m1 kx. So m1 m2 is common, d square x1 by dt square minus d square x2 by dt square. So here both are is d square by dt square is also common, so x1 minus x2, that is equal to here minus kx is the common, so m1 plus m2. So this is the term m1 plus m2 is in this term is equal to outside element, this is the numerator based. So m1 m2 is common, so m1 m2, and here kx is the common, that is m1 plus m2. So m1 plus m2 is equal to outside వచ్చినట్లయితే మన m1 m2 by m1 plus m2, that is d square by dt square is common, x1 minus x2 is equal to minus kx. Here m1 m2 by m1 plus m2 as reduces mass of the system, that is the symbol of nu. Nu is equal to means that is m1 m2 by m1 plus m2, which had dimensions of the mass. U is less than the small of the two masses, and hence the name is reduced mass. Now this value is substituting in this equation, d square by dt square into x1 minus x2 is equal to d square by dt square. Now substituting this value, d square x by dt square plus k by nu into x is equal to 0. Here see, observe that this one is the m1 m2 by m1 plus m2 is equal to reduces mass. This is, you can substituting d square by dt square, this is d square x by dt square value. Here nu this equal to outside వెళ్ళినట్లయితే k by nu అవుతుంది. సో ఈ మైనస్ టర్మ్ అనేది ఈజ్ ఈక్వల్ టు ఇట్ సైడ్ వచ్చినప్పుడు మనకి ప్లస్ అవుతుంది, ప్లస్ k by nu ఇంటూ x is equal to 0. ఇక్కడ రాసింది అది ఈక్వేషన్, d square x by dt square plus k by nu into x is equal to 0. This is the equation of the motion of the one body system equation. This is the fixed point, one mass is connected to this spring. So the motion of the one body of the system is equation is d square x by dt square plus k by nu into x is equal to 0. Now if m1 equal to m2, that is equal to m, we get u is equal to m by 2. If one of the mass of the system is very small, then the reduces mass of the system is corresponding to that of the smaller mass. If m1 is very small, that is u is equal to m1 m2 by m1 plus m2. So you can here, that is m1 by m2 plus m2, same, this equation is simplification, then this is the above equation you can write, u is equal to m1 m2 by m1 plus m2, that is m1 by m2 plus m2. దీన్ని సింప్లిఫికేషన్ చేసినా మనకి ఇదే ఈక్వేషన్ వస్తుంది, దట్ ఈస్ న్యూ ఈజ్ ఈక్వల్ టు m1 m2 by m1 plus m2. ఎల్సిఎం చేసినప్పుడు m1 plus m2, దట్ ఈస్ డినామినేటర్ న్యూమినేటర్కి వెళ్ళినప్పుడు m1 into m2. సో m1 m2 by m1 plus m2 యూ కెన్ రైట్. సో న్యూ ఈజ్ ఈక్వల్ టు m1, న్యూమినేటర్లోకి వెళ్ళినప్పుడు మనకి ఏమవుతుంది 1 plus m1 by m2 హోల్ పవర్ ఆఫ్ -1 అవుతుంది. సో దీన్ని ఎక్స్పాన్షన్ చేసినట్లయితే, బైనామియల్ ఎక్స్పాన్షన్ చేసినప్పుడు మనకి హైయెస్ట్ టర్మ్స్ అన్నీ కూడా నెగ్లిజెన్స్ చేసి ఓన్లీ స్మాల్ టర్మ్స్ తీసుకున్నప్పుడు మనకి దట్ ఈస్ ఈక్వల్ టు m1 into 1 minus m1 by m2 వస్తుంది. సో హియర్ దట్ ఈస్ m1 m2 ఈస్ నియర్లీ ఈక్వల్ టు, సో న్యూ ఈజ్ ఈక్వల్ టు m. సో దిస్ ఈస్ ద reduces mass. ఓకే, సో ఎనీ టూ రెడ్యూసెస్ మాస్లో 2 మాస్ కన్సిడర్ చేసుకొని ఓన్లీ 1 మాస్ అని ఫిక్స్ చేసుకున్నప్పుడు దాని యొక్క డిఫరెన్షియల్ ఈక్వేషన్ అనేది ఫైండ్ అవుట్ చేయడం జరుగుతుంది. ఆ ఫైండ్ అవుట్ నుంచి మనకి రెడ్యూసెస్ మాస్ అనేది దట్ ఈస్ న్యూ ఈజ్ ఈక్వల్ టు m1 m2 బై m1 ప్లస్ m2 ఇస్ ద రెడ్యూసెస్ మాస్. ఈ రెడ్యూసెస్ మాస్ అనేది ఈక్వల్ టు ఓన్లీ న్యూ ఈజ్ ఈక్వల్ టు m1 మాస్. ఆల్రెడీ ఇక్కడ మనం 2 ఈక్వేషన్స్ తీసుకున్నప్పుడు 2 డిఫరెన్షియల్ ఫార్మ్స్ అనేవి ఫైండ్ అవుట్ చేసుకున్నాము. ఈ 2 డిఫరెన్షియల్ ఫార్మ్ తీసుకున్నా కూడా మనకి ఓన్లీ 1 బాడీ సిస్టమ్ విత్ reduces mass connected by the spring to a fixed point అని చెప్పుకున్నాం. సో దట్ ఈస్ nu is equal to m1, that is the reduces mass. And similarly that is the model of the using this formula determine the center of the mass of 3 particles situated at the corners of a right angled in this triangle as shown in this figure. So this is one model of this problem. 3 masses తీసుకొని మనము ఒక యాంగిల్ అనేది ఫైండ్ అవుట్ చేసుకోవడము. సో this is the right angle shape, that is 3 masses, that is m1 m2 m3, and one mass is the 10 kgs and another m2 is the 20 kgs and m3 is the 5 kgs. This is the distance of 1 meter and 3 meters. Center of the mass, that is the center C. So center of the mass is in x direction and y direction only. Let us consider this is the origin point, 3 masses, that is m1 m2 m3, and taken this values at origin. So one point is 0 0 and another one is 1 0 and another point is 1 3. So x axis coordinates of the center of the mass is the C అనుకుంటున్నాం. So now you can apply the center of the mass of in x direction. So m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 m3. So here 3 points is there. So m1 m2 m3. So that's why you can write this is the points 0 0 and 1 0 and 1 3. So x1 y1 x2 y2 x3 y3. So x1 y1 is the 0 0 value and x2 y2 is the 1 0 and x3 y3 is the 1 3 value. So this substituting the center of the mass of the x plane, xcm is equal to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. This is value substituting. So m1 value is 10, m2 is the 20 and m3 is the 5 value. So you can write m1 x1. So here x1 y1 is 0 0 and x2 y2 is the 1 0, x3 and y3 is the 1 3. So kabatti ikkada x1 is 0 and x2 is the 1 and x3 is the 1 by m1 plus m2 plus m3, that is in simplification 25 by 35 is equal to 5 by 7. Similarly y coordinates of the center of the mass C of the system is given by ycm is equal to m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. Here substituting here x1 y1 means 0 and y2 is also 0 and y3 is also 3. So you can write 0 and 0 and 3. m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3, that is equal to 15 by 35. Simplify of 3 by 7. This is the coordination of the center of the mass, that is xcm ycm is equal 5 by 7 and 3 by 7. So in this topic discussion, center of mass of a rigid body and reduces mass. So your center of the mass is that is the position vector of the center of mass, that is rcm is equal to 1 by m integration of r dm. So similarly vcm, the center of the mass of the velocity vcm is equal to 1 by m into summation of I into mi vi. And similarly acceleration acm, the center of mass of the acceleration is equal to 1 by m into summation of mi a. This is the reduces mass of the particles always less than the masses of individually particle constituting the system. And center of mass of the rigid body can be determined by the subdividing the body into a large number of small element of the mass, that is del m, and at the points xi yi zi the coordinates of the center of the masses is the xcm is equal summation of del mi xi by summation of del mi. And similarly y and z center of the masses, coordinates of xi yi zi center of the masses is in this given equations. And center of the masses of the formula in this, that is any two masses masses, that is m1 m2 masses, and origin point nunchi manaki m1 mass ki distance is x1 and m2 mass ki distance is x2. So you can consider center of the mass xcm is equal to m1 x1 plus m2 x2 by m1 plus m2. This is the center of the masses. And simple harmonic motion, a body is said to be moved with simple harmonic motion if the vibrating about it means point such that the force acting on it is always directed towards the center and is proportional to the displacement at any instance of time. These are the summary of the center of mass and center of mass of a rigid body and reduces masses.